Welcome to WABCOWÜRTH webinar ADAS calibration on Volvo. My name is Markus Richter. I'm the key account manager of WABCOWÜRTH, and due to the fact that I take care of the autoglass specialists in our customer group, I'm very well addicted to our ADAS calibration tool, and I'm more or less have been specified onto the tool. So I will guide you through our webinar today and explain you a little bit of our ADAS calibration tool, our W.EASY ADAS calibration tool. So what I would like to tell you is that we have been thinking about the whole topic, quite a bit, and we figured out that the special market about this tool is on glass fitting stations, and it's not even about the stations themselves, it's more about the mobility of the service. So one of our key aspects that we have considered in this tool is that we have a mobile solution. So it's a maximum mobility, and I would say it's the smallest of a kind that we have on the market that is able to calibrate the truck, especially the MAN Scania services and the Volvo and Renault trucks on the geometric driving axle. You will get to know this word a little bit more further on in the webinar, because the geometric driving axle is exactly the standard that we have to fulfill with our solution. And that's something we do. So therefore, we achieve the highest ambitions that we have on the calibrations on the markets of the vehicles. So in this case, we can fulfill 100% of the standards that we have currently on the market. Okay. So as you see here already set up in our in front of me, we have our system. We have a few features that I would like to inform you about up front. We have the possibility to summarize everything, so we move together. I will explain a little bit about the features that we have on top. So we have the calibration scales that we adjust back on the wheels with the wheel clamps that we have. So you see here a mirror and a scale that we need to have. So similar as existing systems on the market. What we do not have is a digitalized screen, for example, and also kind of a beamer solution that competitors have, because this solution is not suitable on the market, especially on mobile service. So just imagine to carry out a screen in such a size as you see it behind of me into a van is quite a risk. I mean, if you buy it from a media store or if you buy it from a television store, you get it in huge cartons and a lot of stuff poured into, so to protect it and bring it home to you, and now you should travel with it in a van on an adjustment is quite risky. So therefore, a mobile solution will not come up in a kind of a digital view. Especially also, as we see today, the Volvo has been calibrated with a target up on a height of 2 meters. I will move on to it further on when we go through the calibration itself. So just imagine to set up such a screen in a height like that, and you really need a huge screen to ensure that you can display the target. Okay, so the wheel clamp itself, I mentioned, is a wheel clamp, very small and very smart, I would say. Smart because the solution fits on sizes from basically the truck range down to the smallest car range. So we can even fulfill, I would say, 14 inches, which is great, because therefore we already fulfill one need also to be able to calibrate cars. And you will be surprised now because we talk about trucks. Yes, exactly. We are the truck and bus specialist on diagnose. That's right. But our solution fulfills the services for cars as well. So we have now let's say an add-on feature where you can easily use existing equipment in your workshop and for cars as well. So you can use basically our solution as the mobility solution for your workshop when you also have to do cars as well. So these wheel clamps fulfill trucks, transporters, LCVs, and cars. And I will now go to the back and will mount it onto the wheel itself. What I will do now first is I show you here a little bit closer. You can see here the grinding of the wrench. You see that? It's self-adjusting. So when I turn the screw down here, you will see it will move in all directions, on both side directions in the same way. So what we do now is when we will set the wheel clamp up on the wheel, on the rim, it will centralize on the center of the axle. And that's important because this is the standard we need to fulfill. Okay, I will now go back to our wheel and so we will switch the cameras. Okay, we have these adjustments here. These little holders will fit onto steel and aluminum rims. On steel rims, we have this little edge within the rim, and you can set it up like this. If you have it on an aluminum rim, you squeeze basically the holder between the rubber and the steel rim. So that is important to know. And on the other side, we have the solution. If you have protecting caps for rims, then you can take these, the other side, you just pull them out like this. And then you switch it. You do it with all four of them, and you can easily adapt this onto cars with protection caps. Okay. So here we go. I will now set up the holder. Important here is if you have a damage on the wheel, on the rim itself, don't worry, set the wheel clamp up like that. Yeah, we ensure always to centralize the clamp with the geometric driving axle. So in this case, any rim damage won't issue us. Okay, so now it's set up. Don't squeeze water out of it because it really needs to fit in a smooth and proper way. If you squeeze too much, it will bend and then it will give you also a wrong picture of the laser spot that is coming onto the mirror in the first step. So there we go. It's now flexible. So we can turn it. That's important. The mirror has to be in the direction of our tool in the first step. And I will now go back to our tool and we will adjust the tool on the geometric driving axle. Okay. So what we need to do first is we have this laser, this centralizing laser here in the setup. So it's included. What we need to do is set the laser up in the front here of the tool, turn it on, and as you can see it here already, it gives you a red line, and you can centralize the tool roughly in front of the truck. And as you can see already through the Volvo logo, we have a rough center here already. We can move the tool a little bit further on. So we are now roughly in the center. Roughly is enough because the reason is we need to hit the laser on the rims, on the wheel clamps, and therefore the highest potential to hit it is if we adjust the tool already roughly in the center. What I have been doing up front is, and this is a little bit more movement, and that's the reason why we have the tool already set up in the distance and also in the height, is you need to ensure that the tool is in the right distance of the truck itself. And how to figure out where the figures are and the distances are, I will guide you through the software in a few minutes and show you where we find all this information. So one of the first distances we need to ensure is 2 meters from the camera to our target. So we have this nice little ladder here in a Volvo where you can climb up. Usually when you work with the glass fitters or when the glass fitters work, they have their working stage up front, so it's a lot easier to handle. In this case, this is not the camera, this is the camera. On an MAN and on a Scania, we have the camera down here. On a Volvo and on a Renault, we have the camera up here. So please ensure, and we have this little holder for our measurement scale, adjust it and pull it down. And we see 2 meters. The tool is set up in 2 meters. Let me hold on a second. I will show you what I mean. There is the holder. Just squeeze it up. Take the measurement. Lock it underneath the magnet that we have here. And hold on a second. There you go. And measure 2 meters. Okay. Important is also, in this case, to take this holder off, because the camera won't see a thing. And you won't believe, but those are complaints of customer that we had. So why isn't the calibration not working here? Because the camera didn't see anything. Okay, so what we have now is we have adjusted the distance. What we need to do as well is the right height. And we will see in the software later on that we need to have 2 meters from the ground to the center of the first markings. Okay, so we achieve 2 meters. Okay, so that's important. We have a few tolerances. You will see that later on in the software. And this is now that we have adjusted the tool from the right distance and from the right height in front of the truck. So what I will do now is I will adjust also the scale that is necessary. Just for your information, the wheel clamp has to be set up on both wheels. So don't be irritated just because we have shown it on one. We have mounted it up front so that we save a bit of time. Okay, so what we have here now is we have this little bar that we pull out in the right distance. Quickly need to check. You have this little green spot that we put down here on the little screw, tied up. Hold on, wrong side. Go like that. You're wondering now why this is down going. That's pretty easy to say. On the other side, it is from the top mounted. The reason is pretty simple, because what we can do is, as you saw it, the bar was pushed out or moved out, pulled out. We can squeeze everything together so that we have this stored in this little bar. And then we need to store the other one underneath here, and to ensure that we have this red line in the center, one has to be mounted down and one has to be mounted on the top. Okay, so we can turn off this laser for the rough center. I will now jump into the software, and afterwards we will adjust the parallelity and the centering of the tool in front of the truck. Okay. So when you open up the software, here we go. When you open up the software, you will see the front screen. And the first thing that we recommend you to do is a diagnose scan. And the easiest way is to identify the truck is to type in what you want to do. So in this case, hold on a second. We type in FH for Volvo, the truck that we are having here. We take the right one from 2013. It also works out to take the identification via the drop-down steps here, but you can also type in a VIN number, okay? The VIN number is yet not perfectly set up on the truck, but we at least give you a direction what kind of truck it could be. Because difference to the car sector is that the VIN number is not located in a centralized step, how it is, a data storage, for example, where we grab the data from. So this is basically the VIN number for trucks and buses has been developed by ourselves. So we have a little indications what kind of truck or bus it is, and then we can further down identify maybe what kind of type it is. But nevertheless, sometimes we have similarity to other vehicles. So the system will tell you, okay, is it a Volvo or is it an Iveco? So in this case, you should be able to identify, okay, it's a Volvo, so we go with that. Okay, here we go. Now we have the Volvo. You have 4 settings here on the left. The 2 of us down are not interesting. Plug position might also be interesting to go to, especially when you're not aware of what kind of truck or when you have identified the truck, where is the plug position, you can easily see, okay, on this side, we have the plug, especially for those who are working permanently with different kinds of trucks. Yeah, sometimes you have a new series of a truck and the plug position has changed. And you can, I mean, this cabin is, I would say, twice as big as a car cabin is, especially from the driver's area. You can waste a lot of time by searching for the right plug. So in this case, we have identified the plug. The plug is already, the system, the diagnose box will now be set on. I will quickly go to the truck, turn the diagnose box on. And important is also, don't forget to turn the ignition on, because only if you have the maximum powered truck, you will get access to all of the components. So the diagnose box is on now. Maybe the colleague, yeah, exactly, he has shown it. The box, the light turned on, and the light will guide us a little bit through the whole diagnose process. And we will see this further on. Okay, we have now the upper functions here in the system. We have systems, and if you see systems, you see all the different EDCs that we have that you can go straight onto. So we could go straight into the driver assistances, for example. But as I mentioned earlier, what we should do is first a system identification. You saw a quick scan and a normal scan. The easy thing is the quick scan has grabs onto informations of the truck, where we have centralized informations about the EDCs, EDU. So we have exactly the knowledge about the components of the truck. So we are starting it. The battery sign is on. We have powered it additionally, so it's not mandatory on trucks because they are really, really easy to handle. We recommend it to do, yeah, but the trucks are not so sensitive as the cars are. So nevertheless, the recommendation is always ensure to have power on, 24 volt, yeah. So the diagnose scan is running through. The diagnose scan up front is necessary because we need to ensure that we have the situation of the truck saved and to ensure, okay, this is what the truck setting is about. Because what you will have is when we do the diagnose scan and you give the truck back to the customer, yeah, all of a sudden the customer realizes, oh, there are major failures on my truck in my dashboard. Yeah, okay, but to be honest, those failures have been on before the truck has been turned into you. So in this case, yeah, ensure to have the standard, you have the overview of the components up front, and at the end, after calibration, please do an outgoing scan and ensure to have the equivalent to see, okay, are the same failures on it as they have been when I turn it back to the customer. And also important to say is when you do the diagnose scan, especially when you're out at the customer's place, yeah, you might have mechanics asking you, okay, can you do a diagnose scan? You get this fancy system from WABCOWÜRTH, great, thanks. Maybe it's an easy thing just to push a few buttons. Yeah, right, it's an easy thing when you have the system, but the system costs money. And if you go to an OE workshop, for example, just the diagnose scan will cost you up to 200 euro, just the diagnose scan. And imagine, yeah, I mean, if I would be in the position, I would just buy a system and go out and do regularly diagnose scan and earn my money with diagnose scan. So in this case, don't give the diagnose scan for free. Yeah, please explain the customer, hey, dear customer, throw 20, 50, whatever euros in my pocket, and we will come along. Okay. So the diagnose scan ran through, and as now is important is to save it to ensure that the tool, that the protocol is saved. That's what we are going to do quickly now. The protocol is saved on the device itself. We take the car registration in. And we save this. So now we have saved the diagnose scan, and we will now go back to our start position. Why we need to go back to our start position? We need to take now the camera out. We can do different ways. We can go via the systems, as I mentioned, to driver assistances. But the easiest way is to go with the search bar and just type in what you want to do. So it's camera what you want to work with. And you already get an information, lane positioning camera with driving, lane positioning camera without driving. What? Didn't this guy say that we can do it without driving? Why is there with driving? Easy to say. Volvo has a two-way solution. So basically the target is set up on the wall and you adjust just the angle and you have to do a test drive afterwards. So in our case, since our solution fulfills the geometric driving axle, we can ensure that we can do the whole process 100% staying, not moving with the truck. So in this case, we fulfill geometric driving axle. This is the requirement from Volvo, therefore 100% static calibration. No need for you to drive, no need for a driver's license. Important. Okay, so we go with the way without driving. It's opening now. We just jump in the function. Okay, it turns down the quick scan now, which is not necessary anymore. Yes, we proceed. And we are now in the camera system. Yep, right. We continue. And you will see it will jump onto the camera component. Okay, here we go. So what we need to do now is function on the left side, calibration, and you will see once more the question, lane position camera with driving, without driving. It doesn't matter what kind of button I press without driving, or if I press help or OK, it will show up the same information. So in this case, since we have a truck here, I can easily step onto it and I can now go through my guidance and see what I need to do. What I will not go into deep is the test conditions, because if I can have a seminar about 60 minutes just about the test conditions. So we will jump through roughly, since we are also running a little bit out of time. As you see now, here are the distances I mentioned earlier. So we have the 2 meters and we have the 2 meters in the height with the tolerance of 10 centimeters. We note, read, and understood. And we will now, as you see here, placement is the distance, the height, and the distance. And we will get further instruction of what we need to do now. Okay? So furthermore, what we need to do is now we need to adjust the parallelity and the centering of the tool. That is what we will now quickly jump into. So the colleagues will now switch a little bit the camera. I will go down to this bar that we have underneath here, a little helping bar that we pull out, because what we need to adjust now is the parallelity. And I quickly need to check. Okay, we have turned on the laser. Turn on the laser. Oh, we need to move out one more. A second. Okay, there we go. I need to adjust the mirror, please. Maybe my cameraman can quickly. Okay, as you can see now, the red spot is down. I will quickly go. We will reflect now. Okay. And we lift up the tool and bring everything on the same amount. I quickly need to check the other side. Okay, there we go. We have a 19 here and we have a 14 here, so we need to meet in the center, which is then 17.5. That's how we set up the tool. There we go, 17.5. Supposed to be on the other side the same. Nope, 16, hold on. 16 and a half, 17. Yeah, 16 and a half, right. Okay, here we go. We will now turn the scale. We have now adjusted the parallelity. That's important. So what we have done now is this angle, okay? And what we need to do in the next step is this, the centering of the tool. For that, I switch onto the scale. Here we go. And you see 29 on this side. We will now go to the other side. And we will see a 10, exactly. So what we need to do now is need to go roughly on to 29, 20. Roughly on 20 we meet. Okay, here we go. Quickly check that. 20, 19 and a half. Okay, here we go. So now the tool is positioned in front of the truck in the proper way. And what we did here is we are now fulfilling the OE regulations. And that is important to know because this setup of the tool is not invented by us. Yeah? It's the OE guidance that we fulfill, and that is always important to know. So what we can do now is we can proceed with the calibration itself. We continue. We have to type in the super pin, which is necessary. You will get the super pin at the moment where you purchase our solution. It is just an additional insurance to hand over this super pin to people who know what to do with the system. So that is important to say. Also, what we have is a specific truck and ADAS license that is necessary also to ensure not to be able to communicate with the engine, with the clutch or something else. So you can be sure you won't destroy anything on the truck. Okay, are you sure you want to perform? Yes, we want. Successfully calibration, that is important to know. So we have done now the calibration. We will proceed and we will be asked, oh, I turned in the ignition. This is nothing more than turning down a computer. That's something we have now done. We turn back on the ignition now. We have waited a few minutes. And at the moment where we turn on the truck back onto the ignition mode, the system is ready to run. Okay. So we have to wait a little bit. Here we go. Yes, we want to save the protocol. Just go on to saving and it's stored back. So now we are in our back position. What we will start now is an additional, hold on, system identification because we need to do the quick scan. That's it. And then we are done. So I would like to let the system run out with the diagnose scan. What I quickly want to mention, yes, you can use to restore the quick scan. Here. Use cancel. Okay, hold on. Reading right would be helpful. Here we go. Proceeded with it. Okay, system is now running. What I would like to mention, two more things is, one thing is our radar plate. We won't be able to show the radar calibration today, but we have a solution for MAN and Scania for the radar, which is a smaller plate like we have up front here. It's a little target about that is placed in front of the truck. And we have the bigger one for Volvo. Quickly need to take off the laser. We can hang on to our system, so it's adjustable. Here we go, second step. Yep, there you go. And it's already placed. The adjustment is basically the same. Open up the file, get out the instructions, and adjust the truck, adjust the tool in front of the truck. And then we are basically done. The last thing I would like to mention is our adapter, our calibration adapter. As you can see it already in the back, we have the target for Volkswagen and MAN. This is the adapter. And the nice thing on this adapter is it fits onto a manufacturer which is very well known on the market for ADAS systems, on multi-brand, a green brand it is. So those targets fit perfectly onto this adapter. So this system can be used further on for cars. Okay. If you have questions about it, do not hesitate to contact us. I would like to say thank you very much, and I would like to refer as well to our next webinar that is coming up. It is about calibrating the MCC, the mirror cam calibration for a Mercedes. Therefore, we have a helpful tool which we would like to introduce to you in the next webinar session. I would like to say thank you very much, and yeah, come back to us as soon as you're interested. Bye.